Hello everyone, welcome back to our channel again. So in this video, we are going to talk more about scalability of a system, okay? So if you remember, so in 2 or 3 videos before this video, we talked about what is scalability, what is availability, and what is reliability for a good system design, right? So now we will dig deeper into scalability, okay? So especially how we can achieve scalability, right? So one very common strategy here is partitioning. So which I believe you will hear a lot in system design. Partitioning, okay? So in this session, we are going to talk about what is partitioning in a scalable system, okay? And how it can solve the scalable and scalability problem, okay? So in previous videos, we talked about to achieve high scalability and also availability, you must use multiple nodes or multiple machines, right? So yes, we will use multiple machines or multiple nodes, okay? But how do we use it to achieve high availability? So in this video, we are going to talk about the very common technique, which is partitioning, okay? So let's say, okay, let's say we have several machines, okay? Yes. Okay. So let's say we have 5 machines, okay? Yes. To achieve high scalability, let's say, yeah, here I have 5 machines to help me achieve high scalability, which means I could accept higher and higher amounts of requests, right? So let's say here the request is storing data. So for example, let's say we are storing users' posts in the Instagram app, okay? So without considering high availability, high scalability, we usually just use one single machine to store all users' posts, maybe in a MySQL database or maybe in a Mongo database or any kind of database you can think of, right? But the point is that without considering scalability issues, you just store it on a single machine, right? But you can imagine as we have more and more users and users are posting more and more photos and medias, so one single machine's disk and one single machine's memory or even its bandwidth cannot handle so much request, right? So we must scale our system by using more machines. So the problem here is how do we use multiple machines, right? So which machine serves which request? So let's say we have a new request, which is from user A and it have a new post. So which machine should store this post, right? So this is what partitioning is solving. This is the problem partitioning is solving. Partitioning is, so to summarize, partitioning's purpose or the goal of partitioning is to see which machine to store which data or which machine to serve which request, okay? So let's say here we have a new request, okay? Okay, here we have a new request. Okay. So with partitioning, we can decide this request should be served by which server, okay? Okay, so we talked about the purpose of partitioning and what problem it solves, okay? So now let's talk about how do we do partitioning, okay? So there are 2 common techniques. So there are 2 techniques to do partitioning, okay? So let's talk about the first one. The first one is called hash number partition. Okay, so what is this? So let's have an example. Okay, so let's say now we have maybe we have 10 requests. Okay, we have request A. Okay, let's see, we have request B, we have request C, D. Okay, cool. So now let's say we have this 10 requests, okay, from A to J, okay. Hash number partition means we will hash the request to some number. For example, based on some field in the request, okay. So one example is when you store a post, the post must have some IDs, right? So you can just do some hash to hash the IDs to some numbers, okay. So let's say now we hash the request A to a number, which is 11. And we hash the number B to some number, which is 26. Okay, so here are all the hashes we got. Let's assume, so I is hashed to number 80, J is hashed to number 99, okay? So in the hash number partition, we will, let's see, okay. We will divide the number from a request. So let's say the number, hash number, we will divide it by the number of servers we have, and then we will take the remainder as on which server we store the request. So let's say, okay, so for request A, so we will divide this 11 by the number of servers, which is 5. So the remainder is 1, right? So then we will store this request on server 1. Okay, so let's see, here is the index of server. Okay, so here it's the 0, this is 1, this is server 2, this is server 3, and this is server 4. Okay, cool. So for request A, the remainder when 11 is divided by 5, which is the number of servers, is 1, right? So we store it on server 1. Okay, and for request B, when you divide 26 by the number of servers, 5, the remainder will also be 1, right? So request B will also be stored or served by server 1, okay? And for request C, 48 divided by 5, and the remainder will be 3, right? So it will be stored on server 3, and we do the same thing for the remaining request, okay? Okay, so after we do the hash for the remaining of the request, so now you can see how the requests are served by different servers, right? So for example, let's say the request is storing a post. So for post C, E, F, and H, they will be stored on server 3. And for request A and B, they will be served or they will be stored on server 1. Okay, so this is how it works. So you can see, yes, we indeed distribute all the requests to different servers, right? Which we achieved high scalability. Let's see what this works when everything is fine, right? So what if, let's say, server 4 is done, okay? What if server 4 is done? So what will happen, okay? So when server 4 is done, we have to do rehash or redistribute all the requests because now we only have 4 servers, right? So based on the calculation, which is hash num divided by the number of servers and take the remainder, right? So we must redistribute the request to different servers, right? So in this case, let's see, when server 4 is done, let's see how it works. Okay, so now we only have 4 servers, right? And let's say we still have the same request. So we must remap the data to different servers, right? Because the number of servers is changed. So for request A, which is whose hash number is 11, so 11 divided by 4, and the remainder will be 3, right? So now request A will be on server 3 now, okay? And for 26, which is request B's hash number, 26 divided by number 4, and the remainder will be 2, okay? So now it will be served by server 2, or it will be stored, the post will be stored on server 2, right? So let's do the same thing for the remaining request, okay? Okay, so now we did the remap. So now you can see on server 0, it stores 4 data, which is CEFI now, right? So if you compare with the previous hash, so for example, on server 0 previously, before server 4 goes down, it stores data 80, but now it has more data stored on it, which is CEF, right? And these 3 data are actually moved from other server, right? So similarly for server 1, actually now instead of storing the previous data, which is 11 and 26, now it actually stores 73, which is from request H now, right? If you compare the previous distribution between servers and now the new distribution, you can see there are, so out of the 10 data or out of the 10 requests, we actually moved 8 of them. So 8 data are moved between the servers now, okay? So, and we only have 10 data, right? So which means 80% of the data are moved among different servers, right? So this is a huge number, right? So which will cost, so the cost will be very high because 80% of data are moved, right? So this is a major problem of this hash number partition, okay? So now let's talk about another way to do this partition, which is very, very commonly used. It is called consistent hashing, okay? So let's say, okay, we still have, okay, let's see, we still have these servers, okay? We still have 5 servers here, okay? And we also still have this 10 same request, okay? Or 10 data, okay? So here, for consistent hashing, we will arrange the servers to a ring, okay? So we will put them as a ring, okay? So this is server 0, 1, 2, 3, 4, okay? So now let's say this is server 0. And this is server 1. And this is server 2. And this is server 3. And this is server 4. Okay? So still we have 5 of servers. But now we arrange them to a ring. Okay? So 0 will be connected to 1. 1, so the next node in the ring is of 1 is 2, okay? And then after 2 it's 3, and after 3 it's 4, and then after 4 it's 0 again, right? So you can see this is a ring, okay? Now let's see with consistent hashing how it works. So in consistent hashing, we still put the numbers, we still convert the request to numbers, okay? So let's say we still converted them to the same numbers, which is for A, it is 11, for data B, it's 26, and for data J, it is 99, okay? So basically, all the data, it will be mapped or it will be hashed to a number from 0 to 99, okay? So all the requests, it will be hashed to 0 to 99, let's say. Okay, so this is the range of our hash number. Okay, so, and in this case, we will distribute the hash range to the 5 servers. Okay, so in this case, let's say server 0, it will handle data whose hash number is from 0 to 25 or 24. Okay, and let's say 1, it will handle, to 19. Okay, sorry. And for server 1, it will handle request from 20 to 39. And for server 2, it will handle request or store data whose hash number is from 40 to 59. Okay, and similarly for number 3 server, it will serve request from 60 to 79. And lastly, this will serve request from 80 to 99. Okay, so you can see here in the ring, okay, we evenly distribute the hash number range, which is from 0 to 99, to all the servers, which is 5 servers right here. Okay, so this is hash ring. Okay, let's put this down. So this is called the hash ring. Okay, cool, this is our hash ring. Okay, now let's see how do we serve the request, or how do we store the data on different servers. So you can see here request A, it is 11, right? So based on the hash ring, so it will be stored on 0 server, okay? And for B, 8 will be stored on server 1. And for C, it will be stored on server 2, okay? Cool. So after we distribute all the requests to different servers based on the hash ring, so here is a distribution, okay? So for example, server 2, it only stores 1 request or 1 data, which is C. And for server 4, it stores 3 requests or 3 data, which is E, I, and J, okay? So yes, this also achieves high scalability because we distribute all the requests and all the data to different servers we have, right? So now let's see what still a similar problem, which is now server 4 goes down, okay? Now server 4 goes down. So let's change the color here. So server 4 goes down, okay? Now how do we redistribute the data, okay? So if you remember it, previously in the hash number partition method, what we do is we redistribute all the data to different servers, again based on the remainder of the hash number divided by the number of currently working servers, right? But here in the hash ring, we will just follow the clockwise direction to put the data on the down server to the next server. So here, let's see, server 4 is done. Now we only have 0, 1, 2, 3, these 4 servers, right? So you can see the data here, EIJ, previously on server 4, right? So we will put this data onto the new server, which is the next server on the ring. So you see number 4, server goes down, the next for server 4, the next server in the hash ring is server 0, right? So now we just distribute this 3 data to server 0 now, okay? Okay, cool. So the data will not be redistributed to other servers. It will only be distributed to the server, which is the next server of the down server in the hash ring, okay? So now in this case, you can see we only moved 3 data out of the 10 data, right? So here, it's only 30% of data moved, which is much, much less than previous one, which is 80%, right? So this is hash ring, okay? So this is consistent hashing. Okay, now let's have another example, okay? So let's say it's not server 4 going down. Let's say it's server 2 going down, okay? So server 2 now goes down, okay? So based on what we set, we check, oh, for server 2, the next available server in the hash ring is server 3. Remember, we have to go to clockwise, okay? So clockwise, in clockwise direction, the next server of the going down server 2 is actually 3. So now we redistribute the data on the original server 2 to the new server, which is 3 now. So in this case, you can see only 1 data out of 10 is moved, right? Which is only 10% data moved. So in previous case, when server 4 is down, it's 30%. Now, if server 2 goes down, it is only 10% data moved, which is, in both cases, it's way less than the previous hash number partition method, which is 80%, right? So you can see hash ring is much better mechanism than the previous one, which is the hash number partition, right? So that's why in modern systems, when they do partitioning, usually they will use consistent hashing. So for example, in your interviews in future to do system design, when you are asked about how do you partition, usually you will use consistent hashing. Okay, cool. So this is the whole content for this video. So let's have a retrospect, okay? So we talked about how to achieve high scalability in a system, which is partitioning mechanism, okay? And the partitioning, we talked about 2 mechanisms. One is hash number partition and one is consistent partition, okay? And consistent hashing is much better than hash number partition because it can avoid too much data move when some server goes down, right? Okay, cool. So hopefully you enjoy this video and you learned something new. So we will talk about more about scalability and availability in our next session. Okay, see you next time. Bye bye.